This question is from AS Physics, October-November 13, paper 23, question 5. You need to understand key concepts such as wavelength, frequency, amplitude, how to derive the speed of a wave formula, how to identify 2 points of a wave and calculate the phase difference, and also how to explain the operation of a ripple tank. Stay with me and we will work through each of these concepts together. Question A. Define for a wave, wavelength. Is the distance between consecutive crests or troughs. Frequency, number of oscillations per unit time. Now, use your definitions to deduce the relationship between wavelength, frequency, and the speed v of the wave. So what is asking is to find a formula that relates all those three variables. So let me start with the general formula for speed. Speed is distance over time. In terms of a wave, the distance is one wavelength, and the time is the time that takes for one wavelength to pass, which is called period. So in terms of abbreviation is lambda over uppercase T. But we know that period is the inverse of a frequency. So doing the substitutions here and reorganize this equation. So here is the numerator and the denominator we are going to flip. So the result is the formula for the speed of a wave is wavelength times frequency. Question B. Plane waves on the surface of water are represented by this picture at one particular instant of time. The waves have frequency 2.5 Hertz. The term for the waves, the amplitude. So amplitude is calculated vertically. So here we have 8 millimeter. So we need to divide this length by 2. And now we have the amplitude, which is 4 millimeter. Question B. Plane waves on the surface of water are represented by this picture at one particular instant of time. The waves have frequency 2.5 Hertz. The term for the waves, the speed. To calculate the speed of the wave, here is the formula. Speed is wavelength times frequency. The frequency was provided, but we need to figure out the wavelength. So how to find this? First, let's draw the equilibrium line on this wave. Now, let's count how many waves you have in 80 centimeters. We have 1, 2, 3.5 plus a quarter right here. So total is 3.75 wavelength we have in fits in 80 centimeters. So what is the size of a single wavelength? So now we need to divide 18 centimeters by 3.75. And then one wavelength is 4.8 centimeters. So now we have the wavelength, we have the frequency, and we can calculate the speed. So in meter, right? In meter, 4.8 meter, because Hertz is in seconds. So we need to convert everything for the metric system, SI base units. And we have 0.048 meters times the frequency is 0.12 meters per second. However, notice that here is provided everything with two significant figures, so we are going to use scientific notation to keep consistent the number of significant figures. The third question is asking to calculate the phase difference between points A and B. To determine the phase difference, so let's look at the position for A and B in this wave. So let's start with this point right here where the wave intersects with the equilibrium line. So in terms of a wave, this is at 0 degrees. So here is 90 degrees, here is 180 degrees, here is 270 degrees, and here is 360 degrees. So the phase difference is point A is at 180, point B is at 360. So the phase difference represented by this Greek letter is 360 minus 180. So the result is 180 degrees. Question C. The wave in B was produced in a ripple tank. Describe briefly, with the aid of a sketch diagram, how the wave may be observed. First, what is a ripple tank? It is a simple device used to study the behavior of waves, including crests and troughs. Let's review ripple tank parts. This is a shallow glass filled with water, and this here is a motor with a flat bar attached to create plane waves. Here is a lamp above the tank to create shadows on the paper underneath the tank. And here is a white paper placed under the tank to display the wave patterns. Here is an example of plane waves on the white paper placed underneath the tank. The bright areas correspond to the wave crests, and the dark areas correspond to the wave troughs, and the distance between two consecutive troughs gives us the wavelength. Likewise, two consecutive bright areas or crests gives us also the same wavelength, and we can measure with a ruler placed on the paper. So here is a brief description about the ripple tank that we have observed the plane waves. A light is positioned above a shallow tank filled with water. A flat attachment connected to a motor creates parallel ripples that travel across the ripple tank. A paper placed under the tank shows the crests as bright regions and the troughs as dark lines. The distance between two consecutive crests or troughs represents the wavelength. And this is the sketch, and this is the distance that we calculate on question B, the wavelength, 4.8 centimeters. So this is the end of the question. Easy, 9 marks for this paper 2.